Humans have not ventured into space beyond low Earth orbit since man's landing on the Moon. But humans are now ready to take another giant leap in space exploration. NASA is planning on sending humans far further than they have ever been before by introducing the new and improved Orion spacecraft to return humans back to the Moon and beyond. The Orion spacecraft is designed to meet the evolving needs of human deep space exploration for decades to come. Orion could carry astronauts to the Gateway Space Facility orbiting around the Moon, and with a lunar lander, travel down to the Moon's surface. Orion will also take humans into deep space and then return them safely to the Earth. Low Earth orbit is an orbit around the Earth with an altitude ranging from 160 kilometers to 2,000 kilometers above the Earth. Low Earth orbit is where the Space Shuttle flew, and the International Space Station now flies. It is where spy satellites and Earth-observing satellites fly. It is where the Hubble telescope and many communication satellites fly. It is also where most of the space junk is located. Orion breaks through this low Earth orbit and ventures into interplanetary space on extended-duration deep space missions, beginning with the trip to the Moon. Other future destinations include near-Earth asteroids, the moons of Mars, and eventually Mars itself. The Orion Multipurpose Crew Vehicle, MPCV, provides an entirely new human space exploration capability beyond low Earth orbit. In addition to deep space missions, Orion is also capable of transporting crew and cargo to the International Space Station. It is also a backup system for the ISS. Orion can remain docked at the International Space Station for up to 6 months. It also has the ability to stay in orbit around the Moon unattended if needed. Orion consists of a cone-shaped crew capsule, a service module, and a spacecraft adapter. Other components include a space launch abort system and, for extended interplanetary travel, a deep space habitat. Orion features dozens of new technological advancements and innovations incorporated into the spacecraft's design. Even new manufacturing techniques have been developed for Orion, such as a self-reacting friction stir welding system, which provides stronger and more durable joints. Some of the component parts are produced using 3D printing, including a baffle, rocket injector, the hatch cover, and over 300 component parts. Since Orion is a reusable craft, its life support, propulsion, thermal protection, and avionics systems have been developed so that they can be upgraded as new technologies and innovations become available in the future. Orion's heat shield is an extremely critical part of the spacecraft. Orion's capsule shape allows it to land in water, like the Apollo missions did when it returns to Earth. A capsule without wings makes it a lot simpler to provide heat protection during re-entry. Due to speeds of around 27,000 miles per hour required for re-entry from deep space missions, Orion's heat shield needs to protect the capsule from temperatures near 5,000 degrees Fahrenheit, more than half of the surface temperature of the Sun. Temperatures capable of melting iron, steel, or chromium. The heat shield's skeleton gives the spacecraft the strength to withstand the craft's impact with the water's surface when it splashes down in the Pacific Ocean. Orion's heat shield, at 16.5 feet in diameter, is the largest heat shield ever constructed. The heat shield's base structure has a titanium truss covered with a composite substrate, or a skin composed of layers of carbon fiber material. A heat-resistant material called AVCOAT then covers the heat shield. Avcoat has been used before on the Apollo spacecraft. This is a glass-filled epoxy Novolac product applied to the composite substrate. 180 unique blocks of Avcoat are machined and then bonded to the heat shield surface. The tiny gaps between the blocks are filled with a mixture that over time becomes solid. Avcoat is the only man-made ablative material that exists today that can handle the extreme temperatures of high-speed re-entry following a deep space mission. The heat shield is designed to be consumed or burned off as Orion re-enters Earth's atmosphere. As the ablator material burns off, it carries heat away from the capsule's structure and provides a layer of cooling between itself and the capsule. Technicians then apply a coat of white epoxy paint to the heat shield surface and apply aluminized tape after the paint surface has dried. The tape absorbs solar heat and infrared emissions. Earlier Orion models applied Avcoat by laboriously injecting the ablative material into each of the 330,000 honeycomb cells, individually. Since the space shuttle could never have left low Earth orbit with its wings and tail, its heat tiles worked fine for the heat levels that it encountered during its returns from low Earth orbit. But tiles like on the space shuttle would not be strong enough for Orion's heat shield, which encounters heat levels significantly hotter than the shuttle ever did. The non-heat shield surface of the capsule is called the back shell, and it's covered with AATB8 tiles. Installed around the pressure vessel and its various external systems are composite backshell panels with titanium honeycomb cores that provide primary thermal control to the spacecraft. A total of 49 composite panels make up Orion's outer shell with additional thermal protection layers installed on top. A total of 970 AETB8 thermal tiles are installed on Orion's backshell. These tiles also protect the capsule from the debris environment or space junk that Orion could encounter while in low Earth orbit. Up to now, space flights for Americans have taken place entirely within low Earth orbit. Since Orion takes astronauts to destinations beyond low Earth orbit, astronauts will travel outside the protective shield of the Earth's atmosphere and magnetic field. Without the protection that the Earth provides, the crew and systems of Orion would be exposed to the full spectrum of space radiation. Orion's new electronics will require additional protection too, more so than ever before. As astronauts venture into interplanetary space, they will be crossing the Van Allen belt, a tightly packed field of radiation around the Earth that protects the Earth and humans from charged ions. Since astronauts will be venturing out for longer duration missions, NASA has had to develop methods of protection from significantly more radiation than astronauts have experienced in the past. New radiation protection elements have been added to protect not only sensitive electronics, but astronauts too. Orion will be able to use materials already stored inside the spacecraft, such as water, food, equipment, and other supplies, which have been shown to offer additional protection against radiation, in addition to the spacecraft itself. Since these items are already stored near the heat shield, this provides a temporary shelter in the aft bay close to the heat shield. Several radiation sensors are located on board to record levels of radiation. Orion may look a lot like the Apollo capsule in shape, but the comparison stops there. Orion is larger than Apollo, 50% more capacity, and this time has a toilet. Where Apollo carried 3 astronauts, today's Orion can carry as many as 6 crew members to and from the International Space Station, and is capable of landing 4 astronauts on the Moon. The crew capsule can withstand the vacuum of space and keeps out salty ocean water upon returning to Earth, protecting critical components. It provides a habitat for the crew, storage for consumables, and holds the majority of Orion's electronics. The crew capsule is the only reusable part of Orion that returns to Earth after each mission. This is the green interior pressure vessel and makes up the core of the crew capsule. The capsule's avionics are described as the brains of the spacecraft. The Vehicle Management Computer delivers more computing power to the Orion spacecraft than any previous crewed spacecraft has in the past. Orion has advanced systems in electrical power, flight control, life support, communications, and a customized software solution. Due to the extreme distances of long-duration missions, Orion's advanced navigation and tracking systems will enable Orion to maintain orientation and communication with the Earth. Its systems move data at a rate 1,000 times faster than the systems on the ISS. The capsule contains what is called a glass cockpit. It is a digital control system evolved from several airplane cockpit designs, including Boeing's 787 multifunction flat-panel multicolor displays. It is outfitted with an auto-dock feature, allowing the spacecraft to dock with the International Space Station automatically, yet has a provision for the flight crew to take over in an emergency. The European Space Agency developed the Orion Service Module, which serves as the primary power and propulsion component of the spacecraft, and is discarded at the end of each mission. It carries rocket engines for propulsion and large solar panels for generating electrical power. It is attached below the crew capsule and provides life-sustaining water, oxygen, and nitrogen needed for a habitable environment, and maintains the temperature of the vehicle's systems and components. Both the crew module and service module are constructed of the aluminum-lithium alloy that was used on the Space Shuttle's external tank. 14-foot protective fairing panels cover the capsule and service module, protecting those components during launch, and are jettisoned after the spacecraft reaches 560,000 feet above the Earth. Orion has 4 solar wings, each 24 feet long, and each wing is made up of 3 panels, each 7 feet by 6 feet. Total power output of the solar cells is 11.2 kilowatts. The original circular solar arrays were discontinued shortly after their first test. The crew module adapter is an interface ring that builds the structural connection between the crew module and the service module. It houses communications, electronics, and power equipment. The Orion MSA diaphragm is a lightweight composite structure that protects astronauts in the crew capsule from hazardous gases produced by the upper stage launch engines. It sits between the propellant stage of the rocket and the crew capsule. The crew capsule and service module join with a deep space habitat for longer deep space missions, or the Gateway Outpost orbiting the Moon. The crew quarters of a deep space habitat provide the crew with radiation and storm shelter protection during solar particle events. They provide, in addition to living quarters, storage areas, science stations, and a galley for food preparation, including a microwave and refrigerator for food heating and storage. After returning to Earth after deep space missions, the capsule will splash down in the Pacific Ocean. Once the heat shield has done its job of getting Orion through the atmosphere, parachutes will take over for the landing. A forward bay cover protects the crew during launch, flight, and re-entry, but must be jettisoned to allow Orion's main parachutes to deploy. After returning from a deep space mission, the forward bay cover is jettisoned at an altitude of 23,000 feet. Drogue parachutes initially slow down the spacecraft, and then 3 smaller pilot parachutes are deployed. Next come the 3 main parachutes. They measure 116 feet across and weigh 300 pounds each, and together can cover a football field. In the event of emergency on the launch pad or during launch, An escape system called Launch Abort System separates the crew module from the launch vehicle using a solid rocket-powered launch abort motor. This abort motor is more powerful than the Atlas booster that launched astronaut John Glenn into orbit in 1962. The Launch Abort System, positioned on a tower atop the crew module, activates within milliseconds to propel the crew module 500 feet in the first 3 seconds and to safety in the event of an emergency during launch or climb to orbit. The Launch Abort System consists of 3 motors: the main abort motor, the attitude control motor, and the jettison motor. Orion is launched into space by NASA's Space Launch System, an advanced heavy-lift vehicle which provides an entirely new capability for science and human exploration beyond Earth's orbit and into interplanetary space. The SLS is NASA's first exploration-class vehicle since the Saturn V rocket took American astronauts to the Moon over 50 years ago. Orion is the safest, most advanced spacecraft ever built. It is flexible and capable enough to take humans to a variety of destinations, including landing on an asteroid and into interplanetary space. After unmanned tests, Orion's next mission will be part of the Artemis I mission, also unmanned. The mission will be the first time Orion launches on the SLS rocket. After the rocket separates, Orion will fly thousands of miles past and around the Moon. After about 3 weeks, Orion will have traveled more than 2 million kilometers, more than 1.3 million miles, and return to Earth. Orion will re-enter the Earth's atmosphere and splash down near a recovery ship off the coast of California. Artemis is an international program with the Lunar Gateway, an international orbital outpost at the Moon. However, contracts in the Artemis program have yet to be given authority to proceed. Under consideration is the possibility that Orion could dock directly with the lunar lander rather than have both the lunar lander and Orion dock at the Gateway, which is no longer considered critical to the program of humans landing on the Moon. Assuming that the next mission, Artemis II, proceeds, Orion will fly past the Moon again. This mission, however, will have a crew and last about 10 days. The flight will be the farthest humans have ever traveled into space. Ultimately, on Artemis III, Orion will take astronauts to either the Lunar Gateway or Lunar Landing Module to descend to the Moon and study the Moon's south pole. NASA has already ordered 3 Orion spacecraft from Lockheed Martin for Artemis missions 3 to 5, and if all goes well, plans to order 3 additional Orion spacecraft for Artemis missions 6 to 8. These Moon missions will be a precursor for astronauts to travel to and explore Mars. The Orion spacecraft will take astronauts on diverse expeditions beyond Earth's orbit, ushering in a new era in human space exploration.